Greetings, B-Siders. My name is Rick Troth. Officially, I'm a data protection specialist. I'd rather think of myself as a rogue programmer, aka hacker, but don't tell my employer. We want to be so squeaky clean for the rest of the world, and the H word has all that baggage. I work for Voltage Security, which is a division of Micro Focus. Now, who the heck is Micro Focus? Micro Focus owns a number of properties, including SUSE. We recently spun off SUSE, but many of you will recognize SUSE, of course, and big player in the Linux distro space. Micro Focus also owns Novell, Attachmate, and some other companies you've probably heard of. In the 80s, the hotness was the Micro Focus COBOL compiler. That's still going strong. COBOL is huge business, even in 2020. And we have one of the more popular compilers out there for that language. Good stuff, Visual COBOL. This is not a vendor pitch. This is about the technology. Specifically, I work in the division known as Voltage. Our main product is SecureData. We also have a product called Secure Mail. That was our historical flagship product. But SecureData got really, really hot about 5-6 years ago with what we call format-preserving encryption. The title of this talk, Risk Grows Where Your Data Goes, and Nobody Knows Like You. Some of you might remember the 1970 hit, Love Grows Where My Rosemary Goes. So the title is a hat tip to that. Ha! But I thought it was cute. I'm looking at you, the audience, as developers, admins, architects, whether you are with the end consumers like maybe Nationwide or Huntington, or if you're with a vendor like me. My goal is that you'll understand data-centric security, data-centric data protection, specifically format-preserving encryption. And at the end of this, you'll come away with, we just gotta have it, like the big cup on at Cold Stone Creamery. A little bit about me. I've been doing Unix for so long and Linux since the early 90s, but even before it was 1.x. I remember using a Linux Linux on a compact laptop, riding on the bus in Houston and banging out code. That was a lot of fun. Linux was this great, wonderful Unix work-alike that was sneaking in the back door at the big data centers. Most of my career, though, has been done with virtualization. Even before VMware, which has been around since 1998, I remember that. VMware 1.0 beta. And in those days, it didn't run on Windows yet. And I thought, this is great. Somebody's doing virtualization on something other than the IBM mainframe. And then later I used Xen, and now I heavily use KVM at home, even on my laptop regularly. But mainframe virtualization goes back even further. Personally, I'm passionate about open source. I spent some time working in academia. In my most recent previous job, we had an in-house SSL stack, and I got to work with that. That's where I popped the hood on crypto stuff. Got bitten, and I'm never going back. Just absolutely loved working with it, tying together symmetric and asymmetric and hashes and all kinds of stuff. In the lower left is this ARRL logo. That's the Amateur Radio Relay League. I am a ham radio operator. I'm taking call signs either by email or in the question and answer session, which follows this. Up at the top, the logo there is for Texas A&M. Two things about Texas A&M, other than the fact that I went there. Tux was created there. The logo for the Linux mascot was done at A&M. And A&M is one of less than 2 dozen universities in the U.S. with a NSA-sponsored Center of Academic Excellence for Cybersecurity. Another one being Cedarville, down outside of Dayton. And I'm hoping to work with them later this year if things all work out and present this technology to those students as well. Data-centric data protection. The goal is ease of use of the data so that you'll have a reduced impact when you're integrating your protection solution with your applications and existing systems and databases. Compare this to the traditional methods, which I would call the easy button, transparent encryption, where the encryption is transparent to the applications. Format-preserving encryption is also transparent to the applications, but provides a different mode of encryption of the data. It allows that the data is processable in the protected state. And this is some really slick stuff. I get really geeked about the technology. A big performance benefit would be that you don't have to decrypt it to use it. For some of the point solutions, the transparent solutions, there's overhead that you just don't realize is there. It winds up making things more secure because you don't have to cross gaps when you jump from one transparent solution to another transparent solution. And we're talking about an industry standard. NIST has blessed this as the AES-FF1 algorithm. Anybody can use it, not just us. So again, not a vendor pitch. This is just about the technology. This is what it looks like. I'm going to get into more detail later, but I wanted to show you as early as possible how this FPE concept works. The ciphertext, the encrypted version, has the same character set and length as the original clear text. So if I've got a social security number 1 2 3 4 5 6 7 8 9, it comes out as still digits. So rather than bits in and bits out, which you would get with straight AES, we have digits in and digits out, or letters in and letters out, or any combination of that. You could encrypt my name and it comes out, it's unpronounceable, but yet still quite printable form that you see here below. You don't have to make any database schema changes. You don't have to make application changes often. Only those applications which are actually ingesting the data would need to be modified, or those which are handing it off out the back door like a credit card number to a bank for reconciliation. The data can stay in this protected form throughout your operation, across all of your applications that need to use that particular data. Good stuff. Someone said that I should add this statement here, that the data could be lying on the sidewalk and still be safe. Imagine that, to where you have a 16-digit credit card number that somebody left on a Post-it note, but it's not the actual credit card number. That's the goal here. And it's a huge boon to you and me trying to defend the privacy and security of our users and customers, because when the bad guys lift it, what they have is just useless. And always, of course, assume that somebody's going to get it. So if somebody's going to get it, what can we do to secure it? Try this, try FPE. Obligatory headline thrown in. This is from earlier this year. There's so many headlines I could have stolen, and in other presentations I've used different ones. You've heard this. This is not anything new to you. These are the headlines that you want to avoid, and I want to avoid, and we want our customers to avoid. Data protection and privacy is an increased problem because of the increased demand for more and faster development of applications, especially with the cloud. More and more stuff is getting automated, and it's just natural that there will be risks. Applications with gaps and vulnerabilities, it's going to happen. So the more we can do to protect things, the better. So in a context of definitely still trying to keep your applications hardened, in fact, my employer sells a terrific product for that. You might have heard of the Fortify product. That's a great way to have your source code scanned, and then you'll just see a lot of vulnerabilities that you can quash right away. But again, not just trying to pitch our products. You do want to continue hardening your apps, but also harden the data itself. Look at it this way. We're dealing with securing identities, access controls. We're also hardening the applications themselves. Here we want to harden the data itself in a way that it's still hardened even when it pops out of a traditional transparent type of solution. Look at it in the development life cycle. That's fine too. Either way, that's what we're trying to do. Just shore up the whole process where we're already hardening identities and applications. Let's also harden the data itself. I mentioned GDPR as the first of several. It's been active for a couple of years now. I should say in force for a couple of years now. We've had some companies already pinched by GDPR for not being compliant or for not shoring up their customers' data as much as they should. And there are countless others. CCPA is a big one in the US because so many companies deal with businesses in the state of California. We've got other states presenting their regulations, and every continent has something, unless you want to go to Antarctica. And the point of this, of course, is the phrase "the new oil." Data is we keep it, we use it, we grow it, we expand, and we collect it. And especially when you think about big data, what is that other than just a perpetual collection of useful information for your business? And you need to make sure that the data itself is safe so that it doesn't walk off. We want to be able to support full scalability and still have mitigation and defense against breaches and all of that. The bigger it gets, the more the risk grows. Threats are all over the place, not just online shopping, but it's bizarre to me to realize that many of us are doing banking from our smartphones. I'm not. I do plenty of other things from my smartphone that make me nervous. Even more nervous is, for me, I get even more nervous when things go into the cloud. With format-preserving encryption, you could have the data protected, push it to the cloud. No problem. I just wish more people knew about it. Of course, social media, that's a whole nother thing. Because you wind up having the relationships themselves. Facebook is constantly trying to tie me together with people. It's a little scary. So that database is something I'd really love to see secured. The regular transparent methods, they're sort of siloed. They're not really well connected with each other, and that leads to scalability problems, but also more significantly, there's so much manual work that would need to be done to eliminate any gaps, and sometimes you just kind of live with the gaps. What I mean is this is a good picture of a half dozen environments or sample systems within your enterprise where you've got something securing the data, but the data then has to be decrypted to be usable. It has to be decrypted when you hand it off to the next phase. Particularly think about database encryption. Transparent database encryption, the underlying storage is encrypted and it's really solid. I mean, it's really good stuff. And it can't walk off and be of use to anybody. But for it to be used by the applications, it has to be decrypted. And at that point, it's exposed. When you need to hand it off from a record into a file, then you're crossing from the database itself down into the file system. File system might be encrypted. Great. But at the handoff, the data is in the clear. At the handoff, that's where the attackers are going to hit you. So at the handoff, if it's format preserved and encrypted, then it's still usable, but also still secured. That's what we want to do. Then your flow, your process flow looks something like this, where you still have all those subsystems, and you may still be using all of the transparent solutions. You could maybe turn off your database encryption. I wouldn't recommend that, but some of our customers have because they don't feel the need. They have other tools in place as far as access, and they have format preserving encryption to keep the data safe when it's when it's at rest and when it's in use. Breaches continue to grow. We hear about them Uh, but the goal of data-centric protection is that when the data leaks, when not if, um, it's of no value to the attacker. It has zero street value. Then the headline would be kind of funny, you know, so and so just lost, had 5 million credit card numbers stolen, but the joke's on the bad guys because those credit cards were protected with some sort of a surrogate scheme like format preserving encryption. The promise is that the protection follows the data. The data itself, since it's encrypted, um, everywhere it goes, everywhere it needs to be used, then it's just the protection's in the same place. The data being usable in that protected form is what lets this happen. That's obviously safer, but it's also faster because you're not having to decrypt the data to use it. And compare that to the transparent solutions. IBM, by the way, is doing very much the same thing. They are now have a solution, data protection passport. Neat idea, where for a given field, they can represent that field by a, um, um, I'm not sure what to really call the object, call it an object, but that object can be carried from one system to another. The problem in their case is the object itself is not just something simple like format preserving encryption. It is kind of more of a blob that has to be processed by compliant applications and databases and subsystems. It does allow that object to walk around from one thing to another, but they've all got to be part of that ecosystem. But with format preserving encryption, you don't have to do that. You can just use the data. You wind up with a lot of existing applications that might not need to change, and not having to rewrite code is a huge boost. This is, of course, most effective for structured data. Start there. We can do unstructured data. That gets a little bit more typical with like whole file encryption. Um, but start with the structured data and then let it flow from there, and you'll get a lot of benefit. This is a couple of slides here on before and after. And again, you've already seen this, but this is the stuff I wanted to show you where I get into some more detail. Let's just look at the credit card number here in the middle. It's obviously clear text here, and so everybody's using it, everybody's just doing fine, except you might have this malware sneak in and pilfer some data, or a rogue user or a rogue employee, heaven forbid, who gets access to that and sneaks off with it. But if the stuff is format preserving encrypted, then you can see this here. This example on the credit card is leaving the leading 6 in the clear, or actually leading 6 in the clear and last 4 in the clear. That's a common mode that our customers use. It's not mandatory. I mean, this is an option that people take. You have flexibility to encrypt the whole credit card or parts of it. And we find that people have to make adjustments. And so one of the things you want to look for when you're looking for a solution like this is make sure that the formats are flexible. So here the data is protected and the malware hits and the rogue users attack, and they don't have anything that they can get that's worthwhile. In fact, simplifying the picture a little bit, malware and bad guys, obviously we want to protect against, but also the DBAs. DBAs aren't bad guys, but in their day-to-day work, they have to touch the data. With format preserving encryption and similar methods, they can do their job without having to look away, and they don't have to worry that they might have seen something. When they go home at night, they can sleep. Format preserving encryption or tokenization or surrogate solutions, that's not the only thing you want. Look also for stateless key management, where keys can be pulled in on demand from a key server. Also look for keys that are derived rather than pre-generated. If you have pre-generated keys, that amounts to a key vault, which becomes yet another high-value target that the bad guys would hit. You don't want that. Similarly with tokenization, if you have a large, and tokenization is even worse because token vaults get to be huge. So they don't they represent a big deployment problem. They don't scale well at all. So look for on-demand access and on-demand key derivation. Of course, the keys can be cached over at the client end for reuse, but you want your clients to be disciplined enough. You want a library in the data protection solution that will discard cached keys after a period of time just to keep things safe, because they can always be refetched by an authorized user. I like the term identity-based encryption. We actually, in the voltage land, we started with our secure mail product, and that's where identity-based encryption started for us. It was an attempt to address the lack of scalability of straight PGP. PGP is wonderful. I'm a huge PGP user, but it doesn't scale so well in the enterprise, and so we had a solution that came up with that, where the encryption was identity based. I still personally, I think of it as identity based because we use the term identity in my world to mean a key name. And that gets a little confusing because you say identity and somebody might think you mean my username. No, but the reason I like it is because you can align key names with functions, with accounts, users, and groups, and things like that. So the term identity-based encryption is really a great thing if you use an identity to refer to the key. Also, when you're dealing with a key name or a key identity and you move from one security district to another, you can still use that same identity. It won't represent the same key because a different key server will present to you a different bit pattern for the key, even though you're using the same identity. Uh, think about having a security district for production data, and it's got its own key server. Then you'd have a different security district for QA or for development. I would recommend multiple security districts, and then within any given security district, the identity will return a different value for the actual key bit pattern. This means that you can do things like take production protected data, drag it over to QA so that you have a large bulk of test data, a large quantity of test data, but it's not at risk because the QA environment, the QA security district will not have the same actual keys. We have used the same name so that the code, as it's flowing from dev to test and then forward into prod, the code doesn't change, and that's kind of essential. You don't want to change the code after you've tested it. So with a given identity for the key, when you go from QA to prod, you're talking about a different key. So the data would, with symmetric cryptography, the data would decrypt, but it wouldn't return the original clear text. So that ugly looking mix of letters for my name would not return Rick Troth in QA. I had mentioned something about the formats that you want them to be flexible. I mean, I showed the example where we have leading 6 clear, the trailing 4 in the clear. You might want all digits encrypted. That's great. So look for flexible protection, flexible formats. We have identities for key names and then formats for the actual kind of processing that gets done. In the payment card industry, they also want things tokenized. Now, at the 30,000 foot level, tokenization and format preserving encryption are really kind of the same thing, but there are specific rules that people need to adhere to. So find ways from the people that you're getting your solutions from to meet the definitions and yet still get the protection that you're looking for. So whether it's called tokenization or FPE, what you're looking for is something where the encrypted version has the same character set or alphabet. We like the term alphabet, the same alphabet as the input and the same length. There is also a difference on that. Embedded format preserving encryption would be where you can, people need to do key rotation, and you probably have already heard about doing key rotation. So how do you do that? You wind up having to decrypt the whole shoot and match and then re-encrypt it. That gets impractical. But with if you can embed the index of the key that was used. Let's say you have a group of keys in a rotation group. There's an index that refers to which one was used, and these rotate like on 2-year cycles or 5-year cycles, so they don't rotate that often. So typically the key groups are fairly small, like maybe a dozen keys or so. So that's not a big number that you would want to throw in alongside the protected data, but you can actually embed it in the ciphertext if you expand the alphabet. So another thing to look for would be embedded format preserving encryption. And then there's the concept of a format preserving hash. A hash, of course, is one way, so it can't be decrypted because mathematically it just doesn't reverse. This is great for the right to be forgotten, where you've got customer says, I really, really, really want you to pretend like we never met, but their data is in your database. You want it non-reversible. A format preserving hash would do that for you. So lots of different things that you want to do here. So look for solutions that are flexible. If you use the algorithm that's put out there in NIST for FF1, you'll get a long way down that road, and look for these other features as well. Essentially, FPE is radix math, and just to explain radix math, it's permutations. It's where you have sets of things, like the letters of the alphabet would be a set of 26 things. And so the radix point would be 26. So with digits, the radix point would be 10. Things like that. But it's just radix math. So the output alphabet or the input alphabet is going to have a radix, and the output alphabet, same thing. Another thing to look for is what I call page integrated encryption. Just to cover all the bases, think about a banking customer who's at home and he's typing in something really sensitive at the browser. Hey, we're HTTPS, everything's cool. Yeah, but when that sensitive data hits the front-end web server, it's in the clear again. With page integrated encryption, you can inject some JavaScript into the web page that will encrypt the sensitive fields, account numbers, and whatever else that you deem sensitive. Encrypt it before he even hits the go button on the web form. And that way, when the sensitive data hits the web server, hits the landing zone, it remains protected. It remains protected after it pops out of the HTTPS tunnel. I got to give a similar talk to this at OWASP earlier this year. OWASP, interestingly enough, has like their top 10 security issues, one being protecting sensitive data. So this is it, guys. Format preserving encryption is the way to do this. Encrypt as early as possible, decrypt as late as possible, leave the data protected as long as possible. Really, you want to encrypt the data at ingestion and decrypt it only when you need to hand it off to a third party. Leave it protected even for your big data stuff that just sits there for years and years and years where you need to do correlation. Again, format preserving encryption retains the referential integrity, so you can do joins and searches and lookups and things like that. I'll mention lookups again in just a minute. And look for platform agnostic mechanisms. One thing that bugs me is when you have a tool or an application or a solution that runs on Windows but not Linux, or maybe it runs on the Unix systems but it doesn't run on the mainframe, or maybe it runs on the mainframe and doesn't run on Windows or something like that. Or you need to use it on the Mac and it's just not available. Look for platform agnostic solutions that just run everywhere. Simple and easy to integrate and recompile for the different platforms. About performance, coming back to this, I've mentioned it already. The traditional transparent solutions often do the whole file, the whole database, at least the whole record. That means your decryption gets a lot heavier. You have to decrypt just to access it, and the decryption winds up covering more than just the individual fields. The data-centric solutions, though, 90% of what we've encountered can work on format preserved data right now. Searches and in particular, I talk about indexing and joins and things like that, but searches, if you need to do a search, don't decrypt the whole database to do a search, just encrypt the search term. and look for that. Easy enough. That's not. I'm not trying to oversimplify things. There are definitely some details you'd want to get into about that, but it's really not that hard to have format preserving encrypted data and still do searches. Got to be able to do searches. That's just obvious. So, um, regulatory compliance. This is some top reasons for using it. Regulatory compliance is a big reason for using it because you've seen just a handful of the regulations that are coming at us. Uh, the payment card industry, they are pretty tight and largely self-policing. They run regular audits. Audits cost money. Any systems which don't have the clear text can be deemed out of scope. You can have a QSA confirm this, and if a system is out of scope, you don't have to audit it. That is real dollar savings right there. Obviously, we're talking about breach protection as well. Um, and scalability, particularly when you get into big data. Think about a data lake where the data is there and it's going to be there for years, but it's protected just in itself. And cloud workloads, pushing the data. I mentioned how sensitive I am about the cloud. If you have the data itself being secured and you push it to the cloud, then I know I would sleep better at night, not worrying about somebody sneaking in and getting some stuff. So about the NIST standard, we worked with them. This is just kind of reviewing some of the concept of FPE, but and it preserves referential integrity. It is a mode of AES. We submitted long before I joined the company. We had our cryptographers work with NIST. Lots of people were working on this at the time. We submitted FF1. Somebody else submitted FF2. There was also FF3. FF1 and FF3 made the cut. FF2 dropped out. FF3 later was found to be flawed and has now been withdrawn. But FF1 is still out there. It's been vetted by lots and lots of much smarter people than myself. I'm not a cryptographer. The math there is just a little more than I can handle. But I know cryptographers, and I know them well enough that I trust them, and they tell us that this stuff really does work. But you want to use an open standard. You don't want to be locked into one particular vendor. This is an algorithm that we put out there, the Voltage team supplied, but it's available to anyone, and several of our competitors are already using it. So it's not just about us. Use standards. Some of our competitors have their own algorithm, and it may be great. It may even be better than AES FF1, but nobody knows because it's wholly proprietary. So you're better off using something that is a published standard. And oh, I should also say that what we originally submitted was slightly tweaked. So we do have a traditional mode. Some of our older customers at my company use an older algorithm called FFSEM. No reason in the world why a given solution cannot handle multiple algorithms. So our solution does, and whatever you employ should also, but should include FF1 because that's the really juicy standard. So coming back around to where we originally started, we want the data to be easily used in a protected form to minimize the integration, the impact of integrating the solution. And you want something that's going to be more enterprise-wide than just the transparent methods. And so that's what format-preserving encryption is all about. Again, if the data can stay protected and not have to be decrypted, so much the better in terms of your performance, and so much the better in terms of your security. And of course, we're talking about a standard. So the lyrics to the song could be expanded, and I hope that kind of rings with you, and maybe I've put an earworm in your heads. Thanks again for listening, and we'll take questions.